Oh, look at this function here, y equals 3 to the x. We recognize this from our work in our last section. This has that basic form, y equals b to the x, right? B to the x, b to the x. This is the basic exponential function. And the base is bigger than 1, so this is a growth function. So we know this function is going to have that shape right there. So let's see what we can do about finding the inverse, and then we'll graph both of them. So first of all, I'll start here, y equals 3 to the x. I will interchange x and y, and then I'll get x equals 3 to the y. Oh, now this is interesting. Now we have to solve for y. So what's interesting here is that we have no way of solving this for y, right? This equation is not this. Now I'm going to erase this in a minute, but it's not this equation. X equals 3y. If it was 3y, I just divide by 3 and we'd be done. But it's not. The y is in the exponent. We have not seen equations like this, so we do not yet have any method for solving this. But not to fear, when we get into a later section in Chapter 6, dealing with logarithms, we'll see exactly how to do this. So for right now, the best we can do is this. We may not be able to solve for y, but we can graph this. So I'm going to graph this first function right here. Y equals 3 to the x. So let's get a little table here. How about if we start at x equals 0, because we know what that does. 3 to the 0 is a 1. Now when x is a 1, we'll get 3 to the 1, so we'll get 3. When x is 2, we'll get 3 squared, which is 9. And you know, if we even use a negative 1, this will be a tough one. 3 to the negative 1, that's a third. That's going to be a little bit hard to plot, but we'll do our best. So let's plot these points. So the first one is going to be 0 and 1. Now that's the basic exponential function. That's what we expected. So this is going to be 0 and 1 right there. And then I'm getting 1 from the origin over 1 up 3. Right, over 1 up 3. And then over 2 up 9. Over 2 way up here to 9. And then at negative 1 we're at a third. Now that's over here. I have to guess that one. Now, as best I can, I'm going to draw a nice smooth curve that passes through these points. Not real smooth. Okay, anyway, that's about the best I think I'm going to be able to do. Now I want to get the inverse. All right, so the inverse, we can get the inverse if we just look at these points here. We're just going to interchange the components. We got 0, 1, we got 1, 3, we got 2, 9, and we've got negative 1 and a third. So let's just switch them to get the inverse, right? Here's f inverse, so 0 goes to 1, so 1 goes to 0, 1 goes to 3, so 3 goes to 1, 2 goes to 9, so 9 goes to 2, and negative 1 goes to a third, so 1/3 goes to negative 1. Let's plot these points. All right, so the first one is over 1 up 0. So over 1 up 0, that's going to over 1 to right 1 right there. And then over 3 up 1. Okay, over 3, 1, 2, 3, up 1, right there. And then what? Over 9 up 2. Okay, so over 9 up 2 puts us here. And then at a third, okay, at a third, I have to kind of guess that one. A third, I'm down to negative 1. All right, so maybe it's like right here. All right, let's pass a smooth curve through these as best we can. Makes a sharp turn here and comes down, approaches that y-axis but never touches it. So what we're saying is that this is the function f. This is its inverse. And do these curves look to you like they are symmetric about that 45-degree line, y equals x? And I will draw that line in here, that y equals x, the 45-degree line. I'll draw it in here as a dashed line. And then we'll be able to see that mirror image? What does it look like to you? Does it look like if you took this F curve, right, take this F curve here and revolve it around the axis like this, that y equals x line, this is y equals x, that this curve is this curve?